Hello children, how are you? Hope you are enjoying the day. This is Rupam Bhatnagar, TGT Maths from Kendriya Vidyalaya Sangathan, RO Delhi region. Welcome to this session of class 7 part 1 of chapter 1 named Integers. First of all, we look into the learning objectives of today's session. They are to let you understand that integers are closed under addition and subtraction. Addition is commutative for integers. Addition is associative for integers. And the integer 0 is the additive identity under addition. First, let us revise that integers are a collection of natural numbers, 0 and negative numbers. They can also be represented on a number line with 0 in between. To the right of 0 are positive numbers and to the left of 0 are negative numbers. Dear students, in your previous class, you have studied about the addition and subtraction of integers on a number line. Before proceeding any further, let us recapitulate it to understand the integers better. Addition of integers on a number line. Let us add -7 and 10 using a number line. We move 10 steps to the right of -7 on the number line and we reach 3. So, -7 plus 10 is 3. Now, let us go for the subtraction of integers. For this, let us take 6 minus 8 on the number line. For this, we move 8 steps to the left of 6 on the number line and we reach -2. So, 6 minus 8 is -2. After understanding the addition and subtraction of integers, we now move to understanding the properties of integers. Moving to the properties of integers, the first property is the closure property of integers. Among them is the closure under addition. Let us now try to add the following pair of integers. 7 plus 3 is 10. Here 7 and 3 are integers and we get 10, which is also an integer. Similarly, in 19 plus -25, we get -6, which is again an integer, and in -20 plus 0, we get -20, which is also an integer. You may try this for any pair of integers of your choice. Now try this yourself. -5 plus 8, is it an integer? Yes or no? Yes, it is an integer, as -5 plus 8 is 3 and 3 is an integer. And in -35 plus -10, is it an integer? Yes or no? Let us see. -35 plus -10 is -45, which is also an integer. We find that the addition of two integers is an integer. Here, check for yourself and see if the integers are closed under addition. On the next slide, you see statements on the left side and their observation on the right side. The first one is done for you. 17 plus 23 is 40 and 40 is an integer, so the result is an integer. The next is -10 plus 3. What is it? It is -7 and -7 is an integer. -75 plus 10. What is it? It is -65 and the result is an integer. -19 plus 25. It gives 6. 6 is an integer. 27 plus -27. What is it? It is 0 and 0 is an integer. -30 plus 0 is -30. Again the result is an integer, and -15 plus -70 is -85, which is again an integer. So you can see for yourself that you will always get an integer. Since the addition of two integers gives an integer, we say that integers are closed under addition. In general, for any two integers a and b, a plus b is an integer. Next is closure under subtraction. Let us observe the following subtractions and see if we get an integer. 7 minus 9 is equal to minus 2. Here 7 and 9 are integers. We get minus 2 on subtraction, which is also an integer. In minus 8 minus minus 14, it is minus 8 plus 14, we get 6, which is again an integer. And in minus 15 minus 0, we get minus 15, which is also an integer. You may try this with any two pairs of integers to see if you get an integer. Try this yourself. The difference of next two pairs of integers given on the screen. 32 minus minus 17. What do you get? Is it an integer? Yes or no? 32 minus minus 17 is actually 32 plus 17, which is 49, and 49 is an integer. Minus 29 minus minus 11. What do you get? Is it an integer? Yes or no? Minus 29 minus minus 11 is actually minus 29 plus 11, which is minus 18, and yes, minus 18 is an integer. We find that the difference of two integers is an integer. Here also, check for yourself and see if the integers are closed under subtraction. On the next slide, you will see statements on the left side and observations on the right side. The first one is done for you. 3 minus 9 gives minus 6, and minus 6 is an integer, so the result is an integer. In the next one, 17 minus minus 21. What is it? It is actually 17 plus 21, which gives 38, and 38 is an integer. In the next one, minus 18 minus minus 14 is 4. It's an integer. Check for yourself. The result will be an integer. In the fourth one, minus 21 minus minus 10 is actually minus 21 plus 10, which is minus 11, and minus 11 is an integer. Similarly, 32 minus minus 17 is 32 plus 17, and again 49, it's an integer. Minus 18 minus minus 18, what is it? Of course, it is 0, and 0 is an integer. Minus 29 minus 0 is minus 29. Here also the result is an integer. What do you observe here? Did you always get an integer? Yes, we always got an integer. Now, since the difference of two integers is an integer, we say that integers are closed under subtraction. In general, for any two integers a and b, a minus b is an integer. Students, we have just seen that just like addition, the integers are also closed under subtraction. Now we know that for whole numbers, if 3 plus 5 is 8, then 5 plus 3 is also 8. That is, addition is commutative for whole numbers. Let us see if it is the same for integers. The next property of integers is called the commutative property of integers. Let us observe the following calculations on addition. Minus 8 plus minus 9 and minus 9 plus minus 8. Are they equal? Yes, they are equal because minus 8 plus minus 9 is minus 17, and minus 9 plus minus 8 is also minus 17. Hence, both give us the same result as minus 17. Similarly, minus 23 plus 32 and 32 plus minus 23 are equal because both give the same result, 9. Minus 45 plus 0 and 0 plus minus 45 are also equal because in both the cases we get the same result as minus 45. Given below are two statements, statement 1 and statement 2. You have to verify whether the two statements in each case are equal or not. In the first one, statement 1 says 17 plus 23, and we all know it is 40. In statement 2, it says 23 plus 17, that is also 40. So, both statement 1 and statement 2 are equal. Similarly, looking into the next one, minus 10 plus 3 or 3 plus minus 10, are they equal? Yes, they are, because both are minus 7. Minus 75 plus 18 and 18 plus minus 75, are they equal? Yes, they are equal, because both are minus 57. 19 plus minus 25 or minus 25 plus 19, will they be equal? Yes, they will be equal, because both will be minus 6. 27 plus minus 27 or minus 27 plus 27, you know very well they are 0 and both are equal. Minus 20 plus 0 or 0 plus minus 20, yes, they are equal, because both are minus 20. So, you observe that in each case both the statements are equal. Here we say that addition is commutative for integers. That is, in general, for any two integers a and b, a plus b is equal to b plus a. So, we see that just like the whole numbers, addition is commutative for integers also. Does this mean that subtraction is also commutative for integers? Let us observe further. Let us perform the following calculations on subtraction. 5 minus 2 is 3 and 2 minus 5 is minus 3. So, 5 minus 2 and 2 minus 5 are not same. Similarly, minus 4 minus 7, they give minus 11, but 7 minus minus 4 is actually 7 plus 4, which is 11. So, minus 4 minus 7 and 7 minus minus 4 are not same. We may take as many examples as possible and verify it. Given below are two statements, statement 1 and statement 2. You have to verify whether the two statements in each case are equal or not. In the first case, the statement 1 is 17 minus 23, which is minus 6, and statement 2 is 23 minus 17, which is 6. Are the two statements equal? No, they are not equal. Similarly, going into other examples, minus 10 minus 3 or 3 minus minus 10, will they be equal? No, because minus 10 minus 3 is minus 13 and 3 minus minus 10 is 13. So, they are not equal. Similarly, minus 75 minus 18 and 18 minus minus 75 are not equal. 19 minus minus 25 and minus 25 minus 19 are also not equal. 27 minus minus 27 is actually 27 plus 27, which is 54, and minus 27 minus 27 is minus 54. So, again they are not equal. Minus 20 minus 0 is minus 20 and 0 minus minus 20 is plus 20, they are not equal. So, you observe that in each case both the statements are not equal. This means that subtraction is not commutative for integers. In general, we say for any two integers a and b, a minus b is and b minus a are not equal. We have observed that though the integers are closed under addition and subtraction, only addition is commutative for integers and subtraction is not commutative for integers. Now, let us talk about more than two integers and observe their addition and subtraction. The next property is the associative property of addition of integers, which involves more than two integers. Let us take any three integers, say for example 2 minus 7 minus 4, and add them in two different ways. First, as 2 plus minus 7 plus minus 4. Here minus 7 and minus 4 are grouped together, and for minus 7 and minus 4 we move 4 steps to the left of minus 7 on the number line and we reach minus 11. Then adding 2 to minus 11 on the number line is 2 steps to the right of minus 11 to reach minus 9. So, 2 plus minus 7 plus minus 4 gives minus 9. Second as 2 plus minus 7 plus minus 4. Here 2 plus minus 7 are grouped together and on the number line we move 7 steps to the left of 2 and reach minus 5. Then adding minus 4 and minus 5 on the number line is 4 steps to the left of minus 5 to reach minus 9. So, 2 plus minus 7 plus minus 4 is also minus 9. We see that the two sums 2 plus minus 7 plus minus 4 and 2 plus minus 7 plus minus 4 are equal. Here you have two statements, statement 1 and statement 2, and you have to calculate and find out whether the two statements are equal or not equal. The first one is done for you. The first says 17 plus 23 plus 6. Here 23 and 6 are grouped, you get 46. In the second statement, 17 and 23 are grouped, you again get 46. So, statement 1 and statement 2 are equal, so the result is equal. In the next one, you have the integers minus 10, 3, 5. In statement 1, 3 and 5 are grouped. In statement 2, minus 10 and 3 are grouped, and still you get minus 2. In the third one, minus 75, 18, minus 3 are given to you. In the statement 1, 18 and minus 3 are grouped, and in the statement 2, minus 75 and 18 are grouped. They are also equal, you can try yourself. In the last one, 19, minus 25, minus 17 integers are given. In statement 1, minus 25 and minus 7 are grouped. In statement 2, 19 and minus 25 are grouped. You can calculate and see that they are also equal. Such additions are always equal, and we say that addition is associative for integers. In general, for any three integers a, b and c, a plus b plus c is equal to a plus b plus c. What about subtraction? Since subtraction is not commutative, it is also not associative for integers. Dear students, so far we have seen that integers are closed under addition and subtraction. Addition is commutative and associative for integers. Subtraction is neither commutative nor associative for integers. In the beginning of my session, we also observed that 0 is in between the positive integers and the negative integers on the number line. This 0 has a role to play in the addition of integers. Let us see. What is the role of 0 in the addition of integers? I have taken two integers minus 1 and 99 and added 0 to them. Minus 1 plus 0 gives minus 1, no change. 99 plus 0 gives 99, no change. You can think of many more integers and add 0 to them and observed. That is, when we add 0 to any integer, we get the same integer. That is why 0 is called the additive identity of integers. In general, for any integer a plus 0 is equal to 0 plus a is equal to a. So, in today's session, let us summarize what we have discussed today. We discussed the sum of integers is an integer or integers are closed under addition. The difference of integers is an integer or integers are closed under subtraction. For any two integers a and b, a plus b is equal to b plus a, or addition is commutative for integers. For any three integers a, b and c, a plus b plus c is equal to a plus b plus c. or addition is associative for integers. When we add 0 to any integer, we get the same integer, and 0 is called the additive identity of integers. Now, dear students, when we learn something, it is always better to revise it, to remember it, and for this we should do some assignments. Let us now do some assignment. There are 4 simple questions and 1 problem solving on the topics that we have learned today. The first question is, take any 2 pairs of integers and verify yourself. First one, the closure property of addition. Next is closure property of subtraction. And third is addition is commutative for integers. Let us see how do we do it. First, we take any 1 pair and verify the above 3 properties. One can find many pairs of integers and each pair will exhibit the above 3 properties. You can choose a variety of pairs and verify the above properties. Question number 2. Write down a pair of integers whose sum is -4 or whose difference is -5. Let us see how to do it. If we need the sum -4, we can have innumerable pairs. I have chosen one such pair as 1 and -5. When I sum them up, I get -4. Similarly, there are many pairs whose sum will be -4. You may choose any one. For the difference to be -5, I have chosen the pair -2 and -7, so that -7 minus -2 gives -5. Similarly, there are many pairs whose difference will be -5. You may select any one. Question 3. Fill in the blanks with the correct integer to make the statement true. The first one, -25 plus something gives -25. 81 plus something gives 0. -13 plus -29 gives -29 plus something. -16 plus 15 plus -17 gives -16 plus something plus something. Now, looking into the answers, -25 plus something gives -25. The integer hasn't changed. The answer is 0. 81 plus something gives 0. Of course, we have to subtract 81, so -81. -13 plus -29 gives -29 plus something. It is the commutative property of addition of integers, so the answer is -13. And in the last one, it is clearly the associative property of integers, so you get 15 and -17 as answers. Question number 4. In a quiz, there are 3 successive rounds in the finals. Team A scored marks -40, 10, 0, and Team B scored 10, 0, -40 in the 3 successive rounds. Now, which team won the quiz and which property of integers is seen here? To solve it, let us first find the total score of both the teams. The total score of Team A is -40 plus 10 plus 0, which is -30, and the total score of Team B is 10 plus 0 plus -40, which is also -30. Now, here both the teams have scored the same total, and the associative property of addition of integers is seen here. Another question. Mr. Pillai had ₹5,000 in his savings account at the beginning of a month. Given below are all the transactions made by him during that month. How will you show that the money paid in the form of an integer and how much money was left in his account after these transactions? The next slide shows the transactions. Amount in the beginning of the month is ₹5,000. Amount deposited in the account for electricity bill is ₹2,500. Amount paid for electricity bill is ₹2,200. Amount deposited for LIC India is ₹1,500, and amount paid to LIC India is actually ₹2,400. So, now we know all the deposited amount and all the paid amount. How to solve it? To solve it, let us look into the answer. take all deposited amount as positive integers and all paid amounts as negative integers and then add them together. In the first case, it was 5,000 and plus 2,500 deposited and minus 2,200 paid. So, total we get 5,300. In the second lot, 5,300 and then 1,500 deposited and 2,400 paid. So, total comes out to be 4,400. So, at the end of the month, he will have rupees 4,400. I hope the above given practice assignment, the topics discussed today have been clear to you. Now is the time for some home assignment. Question number 1. Find the sum of the set of integers given below and verify your answer by using appropriate property of integers. In the first case, 3 integers are given. In the second case, 2 integers are given. In the third case, again 3 integers are given. And in the fourth case, 2 integers are given. Let me give you some hint of the answers. Wherever you have 2 integers, use commutative property of addition of integers, and wherever 3 integers are given, use associative property of addition of integers. You have just to add the set of integers in each case and tell the property of addition used by you. Question number 2. Write a pair of integers whose sum gives a negative integers, or an integer smaller than both the integers, or an integer greater than both the integers. This is a very tricky question, children. I'll just give you a hint how to reach to the answers. Here, first you think of the required integer, whether it's an integer, a negative integer, or a greater integer, or a smaller integer, and then select the pair of integers, add them to get the required integer. And the next question, write a pair of integers whose difference gives 0, or an integer smaller than only one of the integers, or an integer greater than both the integer. Here also, just take up the hint, think of the required integer first, then select the pair of integers, subtract them to get the required integer. Question number 4. Fill in the blanks to make the following statements true. You can see there are questions like minus 5 plus minus 8 is equal to minus 8 plus something. Similarly, the second and the third and the fourth and the fifth question. If you pay attention, students, each question is following any of the property of integers. Here, first read the statement carefully and identify the property, and then you will get the correct answer. In this session, we have understood the properties of addition and subtraction of integers. In the next session, we shall be taking up part 2 of the lesson and try to understand about the multiplication and division of integers. Thank you and have a nice day.